So, theorem, the process xt has normal distribution with mean 0 and variance t cube by 3. Proof. Consider 0 less equal to s0 less than s1 less than s2 dot 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 sn a partition of the interval 0t with sj is equal to tj by n. Okay, and defined xt is t times limit n tends to infinity w s1 plus w s2 dot 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 w sn divided by n. We are now tempted to use central limit theorem, but the random variables ws1 ws2 dot dot wsn are not independent, right? So to use this central limit theorem, we rearrange the above sum as ws1 plus ws2 dot dot wsn is equal to z1 plus z2 plus zn, where 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 zn is equal to wsn minus wsn minus 1 and zn minus 1 is wsn minus 1 minus sn minus 2 times, and zn minus 2 is 3 times wsn minus 2 minus w s n minus 3 dot 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 z1 is n times w s1 minus w s0. Now by the definition of Wiener process, each zj is normally distributed with mean 0 and variance n plus 1 minus j whole square times t by n, right? Just check the time difference between two steps. And also z1 z2 zn are independent, right? So we can apply central limit theorem. Central limit theorem to this z1 z2 zn and get z1 plus z2 plus z3 dot zn follows normally 0, then 1 square plus 2 square plus n square t by n, which is equal to n 0 n into n plus 1 into 2n plus 1 t by 6, right? So t times ws1 plus ws2 plus wsn divided by n follows normal 0 n plus 1 2n plus 1 t cube by 6n square, right? So passing the limit,